In this video, we're going to be taking a look at CAPE 2024, Unit 1, Pure Maths, Question 1. Part A reads, given that f of x is equal to 4 over x minus 5 and g of x is equal to 1 over x, we must find the domain of the composite function f of g of x. First thing that we should do is we should just find out what f of g of x is. So f of x is equal to 4 over x minus 5, and g of x is equal to 1 over x. To find what f of g of x is, basically, wherever I see an x in the expression for f of x, I just put g of x. So there's an x minus 5 in the denominator, so it just becomes a g of x minus 5. And now what's g of x? G of x is 1 over x. So I just put that in. Now I have to simplify. I use a little bit of algebra to simplify because it's a little bit complicated. So I'm going to multiply both the numerator and denominator by x. That's equal to 4x over 1 minus 5x. So that's an expression for my composite function f of g of x. We're asked to find the domain. First thing that we should do is remind ourselves what's the domain. The domain is the set of x values for which the function is defined. And the most important thing that you need to keep in mind for domain questions is just you have to make sure that the denominator is not equal to 0. Or if you have a square root, the thing that's inside the square root has to be greater than or equal to 0. So for here, the denominator is 1 minus 5x. So if I solve 1 minus 5x equals 0, I get x is equal to 1 over 5. So my domain is basically everything except 1 over 5. So I can write this as the domain of the function being the set of x in a set of real numbers x, that's what this means, such that x is not equal to 1 over 5. This is the domain of my function f of g of x. Okay, now let's do part B. Part B is a modulus inequality. It says we have to solve the inequality minus 3 times the absolute value of 2x minus 5 plus 2 is greater than or equal to minus 4. First thing that you should do, the first thing I like to do, is isolate for the modulus in an inequality like this. So if I do that, the first thing I'll do is I'll subtract 2 from both sides. So 3 times the absolute value of 2x plus 5, 2x minus 5, sorry, is greater than or equal to minus 6. The next thing that I want to do is I want to divide by minus 3. But we have to be really careful when we're doing this for inequality questions, because when you divide by a negative, you always have to flip the sign. So I did that. I just make sure and I flip the sign. So I get absolute value of 2x minus 5 is less than or equal to 2. That's my inequality. Now there are two ways that you can branch off when you reach this point. One thing that you can do, which is perfectly valid, is that you can square both sides of this, and when you square it, removes the modulus and then solve the resulting quadratic inequality. That's one thing you can do. But the way that I'll do it is I'll say, okay, if the modulus is less than or equal to 2, that's the same thing as saying that 2x minus 5 is less than or equal to 2, and it's also greater than or equal to minus 2. And if I do that, I just add 5 to both sides. So I got 3 is less than or equal to 2x, less than or equal to 7, or 3 over 2 less than or equal to x, less than or equal to 7 over 2. I'd also like to just show that if we were to do the quadratic method, we're going to get the same answer. So let's just do that, right? So I'm going to start from here, and if I square both sides, I'm going to get 2x minus 5 squared is less than or equal to 4. If I expand this, I'm going to get 4x squared minus 20x plus 25 is less than or equal to 4, or 4x squared minus 20x plus 21 is less than or equal to 0. And if I factorize this, I get 2x minus 3 times 2x minus 7 is less than or equal to 0. So the two roots are at 3 over 2 and 7 over 2. But the important thing is that this is a minimum quadratic curve. It points up, which means it looks something like this. The first root is 3 over 2, and the second root is 7 over 2. And the region that we're asked to find is where it's less than or equal to 0. So it has to be here. In other words, it has to be x being greater than or equal to 3 over 2, but also less than or equal to 7 over 2. And that's exactly the answer that we got via the other method. So both of them are exactly the same. Whichever you prefer, it's up to you. Let's now do part C. This asks us to solve a logarithmic equation, log base 5x minus 4 log base x5 is equal to minus 3. The first thing that you should do with a log equation is you should make sure that all of the bases are the same. And as you can see in this one, they're not the same. So we have to apply a log change of base formula. And The easiest thing to do is to make everything log base 5. So what I'd have to do is I'd have to change the base of log base x5. So that's equal to log base 5 over log base 5x. And what's log base 5? Log base 5 is always 1. In other words, if you take the log of whatever the base is, it's always 1. This is 1 over log base 5x. So now if I substitute that into my equation, I'm going to get log base 5x minus 4 over log base 5x is equal to minus 3. Now let's let y equal log base 5x. So I get y minus 4 over y is equal to minus 3. Or if I multiply by y squared plus 3y minus 4 equals 0. In other words, you can factorize this as y minus y plus 4 times y minus 1 equals 0, or y is equal to minus 4 and y is equal to 1. But we're asked to solve for x. So this is saying log base 5x is equal to minus 4, or log base 5x is equal to 1. And now we just have to undo what log means. This means that just basically take 5 to the power of both sides, and you get x is equal to 5 to the minus 4, or x is equal to 5 to the 1. Well, 5 to the 1 is just 5. You can put this in your calculator. This is just 1 over 625. If you have some extra time in the exam, I highly suggest using this value of x and just checking and making sure that this equation is indeed true. And you'll see that it is. But I mean, that's just like one way to double check rather than just going over all the steps that you did. Because I have found, like, if I just go over all the steps that I do, it's very likely that I overlook the mistake that like if I was to make a mistake, it's very likely that I overlook it because I'm just kind of trusting myself. So it's like, if you do something slightly different to check over, it'll help to help you figure out if you made any errors. Okay, now let's do the last part. It says, prove that the function f of x is equal to 3x minus 2 is bijective. Once again, there are two ways that you can do this. One thing you can do is you can show that the function is injective, and then that it's surjective. And any function that's both injective and surjective is automatically bijective. Another thing that you can do is you can find the inverse, because any function that has an inverse is automatically bijective. So let's do that. The way to find an inverse is I'm going to first start with the function y is equal to 3x minus 2. Then I switch x and y. X is equal to 3y minus 2. And now I have to solve for y. X plus 2 is equal to 3y. Y is equal to x plus 2 over 3. And when I do this, this is equal to f inverse of x. So f inverse of x is equal to x plus 2 over 3. And since f inverse of x exists, f of x is bijective. Bijective. And that's all we had to do for this question. Hi, in this video, we're going to go over CAPE 2024, Unit 1, Pure Maths, Question 2. Let's start with Part A. Part A reads, the roots of the cubic equation x cubed minus 9 equals 0 are alpha, beta, and gamma, and we're asked to find the cubic equation that has roots alpha minus 1, beta minus 1, and gamma minus 1. Given that alpha minus 1 times beta minus 1 plus alpha minus 1 times gamma minus 1 plus beta minus 1 times gamma minus 1 equals 12. Now, when they give you something like this, you should always use it because it'll save you a lot of time. And one thing about Pure Maths is it's not just about knowing how to do everything, you also have to finish in 2 hours and 30 minutes. So anything like this, take it as a blessing and just, don't waste time. Use what they give you, right? So this is a question about Vieta's formula. Let's start by reviewing what Vieta's formula is. Vieta's formula says if you have a cubic of the form ax cubed plus bx squared plus cx plus d equals 0, with roots alpha, beta, and gamma, then alpha plus beta plus gamma equals minus b over a. Alpha beta plus beta gamma plus alpha gamma is equal to c over a. Then alpha beta gamma is equal to minus d over a. Now our cubic equation is x cubed minus 9 equals 0. So for this one, we'd have a is equal to 1, b is equal to 0, c is equal to 0, and d is equal to minus 9. So if we plug this in to our Vieta's formula, we get minus b over a, which is minus 0 over 1. Well, that's just 0. Alpha beta plus beta gamma plus alpha gamma equals C over A, which in this case is equal to 0 over 1. Again, this is 0. And alpha beta gamma is equal to minus D over A, which is minus, and D is minus 9, and A is 1. So this is just 9. So now we have what these things are. I'm asked to find the cubic equation with roots alpha minus 1, beta minus 1, and gamma minus 1. The first thing that we should do is we should find their sum. So that's alpha minus 1 plus beta minus 1 plus gamma minus 1. If I group the like terms, I get alpha plus beta plus gamma minus 3. And I know alpha plus beta plus gamma equals 0. So this is just 0 minus 3, which is minus 3. The next thing I need to do is I need to find alpha minus 1 times beta minus 1 plus alpha minus 1 times gamma minus 1 plus beta minus 1 times gamma minus 1. But the thing is, CAPE has told me that this is 12. So I don't need to worry, I don't need to do any work here. I can save some time. So I'm just going to take this as 12 and move on. However, after this, I solve this problem, I'm just going to talk a little bit more about this, right? But for now, let's just take it as 12. The last thing we need to find is the product, such as alpha minus 1 times beta minus 1 times gamma minus 1. And now we have to spend some time and actually multiply. There are many ways you can do that, but the way I'm going to do it is I'm just going to multiply the first two brackets and then multiply that by the last bracket. So if I multiply the first two brackets, I get alpha beta minus beta plus 1 times gamma minus 1. And then if I multiply these brackets, I get alpha beta gamma minus alpha beta minus alpha gamma plus alpha minus beta gamma plus beta plus gamma minus 1. If I group the like terms, I get alpha beta gamma minus alpha beta plus beta gamma plus alpha gamma plus alpha plus beta plus gamma minus 1. Alpha beta gamma is 9. Alpha beta plus beta gamma plus alpha gamma is 0. And alpha plus beta plus gamma is 0. And then if I plug all of these things in, simply get that it's 8, right? Okay, so now I've found everything I need to know. And to figure out the cubic equation, I just have to use Vieta's formula backwards. And I take A is equal to 1. So that the first term is always going to be x cubed minus, and then the thing that you're going to put here is the sum. So I had minus 3, so it's going to be minus 3 x squared plus, and then the next thing that you put is the product where there's like two terms in each product. So that's plus 12x, and then the last term is just the product, minus 8 is equal to 0. I can simplify this something like this. X cubed plus 3x squared plus 12x minus 8 equals 0. And that's the equation. And if you're in the exam, now is a good time to just move on, right? However, since this is for practice, and it's good practice for you to be able to do this computation, I'm going to still figure out what alpha minus 1 times beta minus 1 plus alpha minus 1 times gamma minus 1 plus beta minus 1 times gamma minus 1 is. Now remember, CAPE has told us that this is 12, so in the actual exam, you don't need to do this. However, I'm doing it so that, just for practice, so you could see like how you would do this, and there's a little lesson afterwards. But for now, let's just do it. So if I multiply it, I get alpha beta minus beta plus 1 plus alpha gamma minus gamma plus 1 plus beta gamma minus beta minus gamma plus 1. If I group the like terms, I get alpha beta plus alpha gamma plus beta gamma minus 2 times alpha plus beta plus gamma, and then plus 3, right? And I know that this is 0 and this is 0. This is just 0 minus 2 times 0 plus 3, which is just 3. But did we make a mistake? Because didn't CAPE tell us that this was 12? So did I make a mistake? Actually, it turns out that CAPE made a mistake, and it is truly 12. It's not, sorry, it is truly 3. It's not actually 12. There's some error that was made. But this brings up the question, what happens in the exam if you get these, if you realize that it's 3, and CAPE is telling you that it's 12, what should you do? Number one thing that you should do is just you shouldn't panic. Either one that you put, because it's CAPE's error, they're going to have to accept either one that you put as being correct, because it's not incorrect for you to assume that they didn't make a mistake. It's just their mistake. Number one thing you must do is you must not panic, and you must not waste too much time on it, right? Of course, if you tried something and you realize that you got a different answer to CAPE, it's very possible that you made the error, so it may be worth your while to double check your work. But if you're double checking and triple checking and you seem to see no error, it is also very possible. CAPE has many times made mistakes in the past. So it's not something that you should lose too much sleep over, especially considering the highly time-sensitive pressure that you will be under. Just put something. Remember, also you get marks for process. So if it was like an arithmetic error that you made somewhere, you're still going to get a lot of marks for the correct statements and derivations along the way. So the number one thing to do is not panic and don't waste time, okay? All right, that's all I wanted to say for part A. Let's move on now to part B. Part B reads, the function f of x equals 2x cubed minus px squared plus qx minus 5. It's divisible by 2x minus 1, and it has a remainder of 7 when divided by x minus 1. And then we have to figure out what p and q are. This question will always be about two things. It's all about remainder theorem and factor theorem. So let's remind ourselves what they are. Remainder theorem says if f of x is divided by x minus a, the remainder is f of a. And factor theorem says if f of x is divisible by x minus a, then f of a equals 0. So we have to use these two. Because they're two unknowns, p and q, we have to get simultaneous equations, and then we have to solve them simultaneously, right? So let's go. The first thing is that it's divisible by 2x minus 1. So since f of x is divisible by 2x minus 1, by the factor theorem, f of 1/2 equals 0. The way I got 1/2 is if you set 2x minus 1 equals 0, you'd get that x is 1/2. That's how I got the 1/2 to plug in here. So that means that 2 times 1/2 cubed minus p times 1/2 squared plus q times 1/2 minus 5 equals 0. And that means if I expand out, this is 1 over 4 minus p over 4 plus q over 2 minus 5 equals 0. Multiply by 4, 1 minus p plus 2q minus 20 equals 0, or 2q minus p equals 19. That's equation 1. What's equation 2? Well, I know the remainder when f of x is divided by x minus 1, it's 7. That's what the question is saying. So by remainder theorem, f of 1, this one here, equals 7. So what does that mean now? Well, I can just put 2. I'm just putting in x is equal to 1 into this expression right here for f of x. So 2 times 1 cubed minus p times 1 squared plus q times 1 minus 5 equals 7. So that's 2 minus p plus q minus 5 is equal to 7. So that means that q minus p, if I just simplify, q minus p equals 10. This is equation 2. So you have two equations. You can just solve them simultaneously however you want. The way I would do it is I just do 1 minus 2. That just gives me q on the left-hand side, and that's just equal to 9. And then if we call this 3, if I do 3 into 2, if I substitute 3 into 2, I get 9 minus p is equal to 10. Therefore, p is equal to minus 1. So those are my two values for p and q. Now let's do part C, which I think was the most difficult question in this entire paper. It's also something that CAPE has not asked before, this particular type of question, but it is in the syllabus. So it's a good idea for you to get used to the techniques used to answer this question, because it's very possible that they ask this again. Question 3 reads, let P be the proposition that if n cubed plus 3 is odd, then n is even for all integers n, and we're asked to provide a proof by contradiction of this proposition. Just to let you know, a proof by contradiction, what that means is like You're going to prove something is true by assuming that it's false and then showing something that can't be true happens. So that means that your assumption was wrong. So for example, if I wanted to prove by contradiction that there is no biggest number, I can assume by contradiction that there is a biggest number, but then if I add 1 to that number, I get a bigger number. So that's a contradiction, because then the number that I made couldn't have been the biggest number. So that's an example of a proof by contradiction. And CAPE gives us a hint as well to explain what the proof by contradiction is. So what we're going to do is we're going to let n cubed plus 3 be odd, and we're going to assume that n is odd, and we're going to use that, or we're going to show that this assumption can't be possible, or it leads to something that's incorrect. Let's first start by reviewing what even and odd integers are. So an even integer, what it means is that you can write the number n, let's say n was even, you can write it as 2k for an integer k. So the even numbers are like 2, 4, 6, 8, etc. And the defining property is you can write it as 2 times another integer. Now odd integers are just all the integers that you can't do this for, but you also have a way to write an odd integer, which is instead of 2k, 2k plus 1. So for example, 1 is 2 times 0 plus 1. And the odd integers are like 1, 3, 5, 7, 9, etc. That's all you really need to know about even and odd numbers to solve this problem. So now let's actually begin the proof. Let n cubed plus 3 be odd, and assume by contradiction that n is odd. Since n is odd, you can write n is equal to 2 times k plus 1 for an integer k. And since you have this, I can plug this in to my other thing that I know, which is n cubed plus 3. So n cubed plus 3, that's equal to 2k plus 1 cubed plus 3, right? And now I can expand this brackets however you want. It's a cubic. You can use binomial theorem if you want, but the way I'm going to do it is like this. I can write this as 2k plus 1 squared times 2k plus 1 plus 3. If I expand the perfect square, 4k squared plus 4k plus 1 times 2k plus 1 plus 3. And now if I multiply these two brackets, 8k cubed plus 4k squared plus 8k squared plus 4k plus 2k plus 1, and then plus 3. And if I group the like terms, 8k cubed plus 12k squared plus 6k plus 4. But the important thing is a complicated expression, but we don't need to do much more. All we need to notice is that I can factor a 2 from this. 2 times 4k cubed plus 6k squared plus 3k plus 2. So what I've just shown is that n cubed plus 3, I can write it as 2 times another integer. But from what we know about even and odd integers, this means that n cubed plus 3 is even. However, we know that n cubed plus 3 is odd. So this is a contradiction, because a number can't be both even and odd at the same time. And when you get a contradiction, what it means is that your original assumption, so we assumed that n is odd, that's incorrect. So since n is not odd, n is even. And that's exactly what we were asked to show. In this video, we're going to solve CAPE 2024 Pure Maths Unit 1, Question 3. Part A reads, express 5 sine theta plus 12 cosine theta in the form r sine theta plus alpha, where r is bigger than 0 and 0 is less than alpha less than 2 pi. First thing you should see is when 0 is less than alpha less than 2 pi, that means that alpha is in radians. Just make sure that your calculator is always in radians for questions like these, because if it's in degrees, you're just going to have the wrong answer. So that's an important thing to just double check. Okay, so now to solve this, what we're going to do is we're going to write 5 sine theta plus 12 cosine theta is equal to r sine theta plus alpha. And our job is to solve for r and alpha. The way we're going to do that is we're going to expand the right-hand side using the sine sum formula, which is r sine theta cosine alpha plus r cosine theta sine alpha I can rewrite this as r cosine alpha sine theta plus r sine alpha cosine theta. And I want this to be equal to 5 sine theta plus 12 cosine theta. So what I'm going to do is I'm going to equate the coefficients. So for example, the coefficient of sine theta on both sides, on one side is 5 and on the other side is r cosine alpha. So what I'm going to say is r cosine alpha equals 5. And similarly, the coefficient of cosine theta is 12 here, and then the coefficient of cosine theta is r sine alpha. So the next equation is r sine alpha equals 12. I just have to solve these simultaneously. So the first thing I can do is I can square, let's say this is equation 1, and this is equation 2. If I do 1 squared plus 2 squared, I'm going to get r squared cosine squared alpha plus r squared sine squared alpha equals 5 squared plus 12 squared. And we know that cosine squared alpha plus sine squared alpha is always 1. So that just means that r squared is equal to 5 squared plus 12 squared, which just means that r is the square root of 5 squared plus 12 squared. And if you just put this in the calculator, you're going to get 13. So that's r. And then what's alpha? Well, if I take 2 divided by 1, I get sine alpha over cosine alpha. And sine over cosine is just tan alpha is equal to 12 over 5. So that means that alpha is just tan inverse 12 over 5. And you'll see that this is 1.176 radians, right? So the way that you'd express it is 5 sine theta plus 12 cosine theta is equal to 13 sine theta plus 1.176. Okay, so that's how you do part 1. Part 2 asks us to show that 5 sine theta plus 12 cosine theta plus 7 is less than or equal to 20. So usually when you have this question and the next part is some kind of inequality, you have to use the first part. So the way that we're going to do this is we're going to just use what we just figured out from the first part. So 5 sine theta plus 12 cosine theta plus 7 is equal to 13 sine theta plus 1.176 plus 7. And the next step is that we have to realize that sine theta, the important thing that you need to know about both sine and cosine is that sine theta is always less than or equal to 1 and greater than or equal to minus 1. But in this case, what we really just need is that it's less than or equal to 1. So I can say that this is less than or equal to 13 times 1 plus 7. And 13 times 1 is just 13. Plus 7 is 20. So indeed, the expression is less than or equal to 20, like we're asked to show. So now do part B. Part B first asks us to show that 2 sine x plus 3 cosine x equals 3 can be rewritten in the form 13 cos squared x minus 18 cos x plus 5 equals 0. So if you look at the thing that they're asking us to show, there is no sine x. So basically what we have to do is get rid of sine x. And the way we're going to do that is by the trigonometric identity, sine squared x plus cos squared x equals 1. So how do we do that? Let's start with our equation. 2 sine x plus 3 cosine x equals 3. Let's then move the cosine x to the other side. So 2 sine x is equal to 3 minus 3 cos x. Now let's square both sides. 4 sine squared x is equal to 9 plus 9 cos squared x minus 18 cosine x. Now, the way I expanded this right hand side is 8a minus b all squared. So that's a squared plus b squared minus 2ab. Now what I'm going to do is I'm going to say, okay, this is 4 times 1 minus cosine squared x equal to 9 plus 9 cosine squared x minus 18 cosine x. And then, okay, this is 4 minus 4 cosine squared x is equal to 9 plus 9 cosine squared x minus 18 cosine x. And then if I just collect the terms on the right hand side, I get 0 is equal to 13 cosine squared x minus 18 cosine x plus 5. And that's the exact equation that we're asked to show. Now let's move on to part 2. We're asked to solve this equation. The same equation for minus pi less than or equal to x less than or equal to pi. Keep in mind, once again, this is in radians. So the way that we're going to do that is we're going to use the same form, the form that we just found. So we've just shown that it's the same thing to just solve 13 cosine squared x minus 18 cosine x plus 5 equals 0. if I was to let y equal cosine x, then this is like 13y squared minus 18y plus 5 equals 0. This is a quadratic, solve that however you want. The one way that you can do it is you can factorize. If you factorize this, you're going to get y minus 1 times 13y minus 5 equals 0. And then that means that the two solutions are y equals 1 and y equals 5 over 13. But we're asked to solve for x, so we can't just leave it like that. So this cosine x is equal to 1 and cosine x is equal to 5 over 13. Let's do the cosine x is equal to 5 over 13 first. You have to, the first thing that you should do is figure out what the principal value is. If you were to just do cosine inverse of 5 over 13 in your calculator, you get 1.176. Now, here it's cosine x is positive, so if we draw our quadrant, it's going to be ASTC. All school teachers care, that's how I remember it. And cosine is positive, so the two ones that we care about are this one and this one. So we have to figure out what angle. So the first thing is we just showed that this would be 1.176. And then the next one is we have to figure out, well, what angle is that? If you look at the range though, they said that the angle is allowed to be negative. So actually our angle will just be the negative of this, minus 1.176. So those are two solutions corresponding to that value of cosine x. The next one is for cosine x is equal to 1. For this one, what's the principal value? The principal value is actually just 0. If you put cosine inverse of 1 in your calculator, you just get 0. So now, in the same thing, the angle is actually just here. And even in the fourth quadrant, it'll be the same thing. In other words, because minus 0 is 0. So actually, the only solution here is just x equals 0. So these together are the three solutions for this equation. Let's move on to the last part, which is a trigonometric proof. It asks us to show that 2 cos squared x minus 1 squared all over cosine 4x minus sine 4x is equal to 1 minus 2 sine squared x. I suggest when you have to pick a side to start working with, you pick the side that's a little more complicated, because usually it just means that you have more things that you can work with on that side. If I start with 1 minus 2 sine squared x, what can I do then? Seems a bit difficult, but the left-hand side, because it's complicated, there's so many things I can try. So let's start with the left-hand side. That's 2 cos squared x minus 1 squared all over cos 4x minus sine 4x. The denominator is the difference of squares. What that means is I can write it like this: 2 cos squared x minus 1 squared all over cos squared x squared minus sine squared x squared. And a squared minus b squared is equal to a minus b times a plus b. So I'm not doing anything with the numerator. What I'm saying is that this is cos squared x minus sine squared x times cos squared x plus sine squared x. But cos squared x plus sine squared x is 1. So I can say that this is equal to 2 cos squared x minus 1 squared all over cos squared x minus sine squared x. Since cos squared x plus sine squared x equals 1. So now what I'm going to do is I'm going to replace this sine squared x by 1 minus cos squared x. So if I do that, all over cos squared x minus 1 minus cos squared x, I actually see that what I get on the denominator is actually the same thing as what I had on the numerator. It's 2 cos squared x minus 1 all squared all over 2 cos squared x minus 1. So that means that I can just remove 1 from the power of the numerator, so it's just 2 cos squared x minus 1, and I'm really close. But the only thing is my expression is in terms of cos squared, and the right-hand side is in terms of sine squared. So what do you think I'm going to do? I'm just going to say, okay, well, cos squared is 1 minus sine squared x. So 2 times 1 minus sine squared x minus 1, which is equal to 2 minus 2 sine squared x minus 1. And then if I collect the 2 and the 1, that's just 1 minus 2 sine squared x. And boom, that's exactly what we wanted to show. So we're done. In this video, we're going to look at question 4 of CAPE 2024 Pure Maths Unit 1. Part A reads, a plane P passes through the point 5, 1, minus 3 and it's perpendicular to the vector n, which is 3i minus 4j plus 2k. And we're asked to find the equation of the plane. So the first thing that we should do is basically we just have to recall what the formula for the equation of the plane is. And let's say the normal vector is ai plus bj plus ck, and the passes through the point x0, y0, z0. Then the equation of the plane is a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0. So for our question here, a is equal to 3, b is equal to minus 4, and c is equal to 2. That's the normal vector. And then x0 is equal to 5, y0 is equal to 1, and z0 is equal to minus 3. That's the point it's passing through. So if I just put all these things into my equation becomes 3 times x minus 5 minus 4 times y minus 1 plus 2 times z plus 3 equals 0. Now if I just expand 3x minus 15 minus 4y plus 4 plus 2z plus 6 equals 0, or 3x minus 4y plus 2z, and then the last term is minus 5 equals 0, and that's the same thing that they asked us to show. Now we're asked to find the angle in radians between this plane and the plane with equation 7x minus 4y plus 3z is equal to 5. When we're asked to find the angle between two planes, all you really need is the normal vector. So for our first plane, we know that our normal vector, let's call it n1, is equal to 3 minus 4, 2, right? I mean, this was given in the question, but you can also see it just by looking at the coefficient of x, and then the coefficient of y and the coefficient of z. Similarly, for this plane, the second plane, the normal vector is going to be 7 minus 4 and 3. It's just reading off what the coefficient of x, y, and z are respectively. To find the angle between the two planes, now we have to find the angle between these two vectors. And the way that we have to do that is using the formula cosine theta is the dot product of the two vectors over the product of their absolute values. So just to remind you what the dot product of two vectors is, I just take the x's and I multiply them together, then I add the y's multiplied together, and then I add the z's multiplied together, and then all over. Now to find the absolute value, what I have to do is I have to take the square root of everything squared, the sum of all the squares. So for example, n1, which is 3 minus 4 and 2, it's the square root of 3 squared plus minus 4 squared plus 2 squared, and then similarly for n2, it's going to be square root of 7 squared plus minus 4 squared plus 3 squared. Just when you're doing this, make sure that the minus is inside the square, because it'll change your answer if it's outside the square, right? So now if you do this and plug it all into your calculator, what will you get? You're going to get 21 here plus 16 plus 6 all over square root of 29 times square root of 74. Now when you put this into your calculator, you're going to get this is equal to 0.928. Then, but this is cosine theta, so what's the actual value of theta? Keep in mind that your angle, they said it has to be in radians, so theta is equal to cos inverse of 0.928, which is about 0.381, right? So that's how you'd find the angle. And always keep in mind what they're asking you, what units they're asking you for, because they could equally ask you for it in degrees, and then you have to find the angle in degrees. Okay, let's move on now to part B. That says the equation of a circle is given as x squared plus y squared minus 6x minus 8y minus 39 is equal to 0, and we're asked to find the center and the radius of the circle. Now, there's a formula that you can't just memorize if you need to, but I always find it easier to just complete the square on both sides. So let me just show you what that is like. What I'm going to do is I'm going to take this equation, and the first thing is I'm going to put the x terms together, and then the y terms together. and then I bring the 39 on the other side. So x squared minus 6x plus y squared minus 8y is equal to 39. Now I'm going to complete the square for both the x and the y term. So to do that, what I have to do is I have to take the 6 divided by 2 and add the square of it, so plus 3 squared. Similarly here, y squared minus 8y, take the 8 divided by 2, it's 4, so then plus 4 squared. And now to keep the equality, I have to add that same thing. So I added a 3 squared and I also added a 4 squared, like this. And now this here is going to be equal to x minus 3 all squared. And then similarly, this is equal to y minus 4 all squared. If I add all of these things together, I get 64. And from this form, I can tell what the center of the circle is. The center of the circle is 3, 4. That's just like the x coordinate will be what's x minus, and then the y coordinate will be what it is, like y minus. And then the radius, it's always the square root of what's on the right hand side. So it's the square root of 64, which is just 8. Let's move on to part 2 now. It says find the equation of the tangent to the circle at the point 11, 4. So when I asked to find the equation of the tangent, the first thing that we should do is find the gradient of the radius. Well, the radius passes through 11, 4, because that's the point, and the radius also passes through the center. So it also passes through 3, 4. So these are the 2 points. So therefore, the gradient is y2 minus y1, which is 4 minus 4, all over 11 minus 3, which is just 0. This means that the radius is a horizontal line. And since the tangent is perpendicular to the radius, this means that the tangent is a vertical line. So the equation of the tangent is just going to be x is equal to a constant. And since it passes through the point 11, 4, the equation of the tangent simply has to be x is equal to 11. Let's now do part C. Part C reads, a point Q moves in the xy plane such that it is equidistant from A, which is 2, minus 5, and B, which is minus 2, 3. Find the locus of Q. Basically, this comes down to translating in terms of equations what it said in English there, that is equidistant from A and B. So let's say that Q is x and y. What's the distance from Q to A? Well, that's going to be, this is by Pythagoras' formula, x minus 2 squared plus y plus 5 squared. Now the distance, similarly, I'm just going to find what's the distance from Q to B. That's going to be the square root of x plus 2 squared plus y minus 3 squared. And because it's equidistant, these two things have to be equal. So I can equate these two things and then cancel the square roots. So I got x minus 2 squared plus y plus 5 squared equals x plus 2 squared plus y minus 3 squared. Now I'm going to expand all of these brackets. So I have x squared minus 4x plus 4 plus y squared plus 10y plus 25 equals x squared plus 4x plus 4 plus y squared minus 6y plus 9. The x squared terms will cancel, the y squared terms will cancel. And now I'm going to group everything by bringing all the y's to the left-hand side and then everything else to the right-hand side. So the left-hand side is just 16y. The right-hand side is going to be 8x. And then if I look at all the constant terms, I'm just going to get minus 16. So then I divide by 16, and I get that y is equal to x over 2 minus 1. And that's the equation of the locus. Whenever, just for your information, if it's the locus of the points which are equidistant from two different points, the equation is always going to end up being a line. In this video, we're going to look at CAPE 2024 Pure Maths, Unit 1, Question 5. Part A reads, a function f is defined as f of x equals x plus 4 cubed if x is less than minus 2. It's equal to minus 10 if x equals minus 2. And then it's equal to x squared plus 8x minus 1 when x is bigger than minus 2. The first part asks us to find out what f of minus 2 is. The main thing you have to do here is you just have to go, this is called a piecewise definition for f. You just have to figure out which piece x equals minus 2 is in. And x equals minus 2 is in the piece x is equal to minus 2. So f of minus 2 is simply minus 10. So you can just write f of minus 2 equals minus 10. Don't overthink a question like this. And next way, that might help you realize like this is kind of a simple question. You see that it's only worth 1 point. So there's not much work really that they're expecting you to do. Okay, this next part asks us to find the limit as x approaches minus 2 of f of x. Now, to do this, we have to remember the concepts of left-hand limit and right-hand limit, or limit from above and limit from below. So just to remind you, the limit as x approaches 2 from below, let's say, of f of x, what it means is that as x approaches minus 2, while being less than minus 2, what is the limit? What does f of x approach? Well, in this case, when x is less than minus 2, it's this function, right? So it's limit as x approaches minus 2 of x plus 4 cubed. And then this is a polynomial, so once it's a simple function like this, you can just put in minus 2. So this is equal to minus 2 plus 4 cubed, which is simply 2 cubed, which is equal to 8. Now we're going to do the same thing for the limit from above. So the limit as x approaches 2 from above now of f of x equals the limit as x approaches minus 2 from above of x squared plus 8x minus 1, which is equal to minus 2 squared plus 8 times minus 2 times minus 2 minus 1. And if I do this, I get 4 minus 16 minus 1, which is minus 13. So the important thing to take away is that these two things are not equal. You can see this one is 8 and this one is 13. When they're not equal, this means that the limit, so let's say these limits are not equal, and it means that the actual limit, the limit as x approaches 2, minus 2 of f of x, does not exist. So it's a DNE. Because when you go from the left, or when you go from below minus 2, you get one thing, and then when you go from above minus 2, you get another thing. So there's no one value that you can assign to these things. Okay, next question now. Let's determine whether f is continuous at x is equal to 2. To remind you, what does it mean for a function to be continuous? F is continuous at, let's say, a point A if the limit as x approaches A of f of x equals f of A. So now here we're taking A is equal to minus 2. Well, f of A, as we just saw, is equal to minus 10. And the limit as x approaches A of f of x is a DNE. So these obviously can't be equal, hence f is not continuous. Now we're asked to evaluate the limit as theta approaches 0 of sine theta over sine 4 theta. Let me just show you a kind of like a way that will help you figure out what the answer should be. What you should, like the main point of this question is you need to remember that the limit as or let's say limit as theta approaches 0 of sine theta over theta is equal to 1. Now what this means is that sine theta, when theta approaches 0, is approximately equal to theta, right? This is something that you use if you're taking a physics class. This is an approximation that you use all the time. So without actually proving it, what I can say is, okay, since sine theta is approximately theta, sine 4 theta will approximately be 4 theta as well. So this limit will just be approximately theta over 4 theta. So it should be 1 over 4. So you should expect the answer to be 1 over 4, but let's actually prove it now. Let me show you the rigorous way to prove it. So the limit as theta approaches 0 of sine theta over sine 4 theta, because we just saw that we want to basically replace the sine theta with theta, what I'm going to do is I'm going to multiply and divide by sine theta. So I can do that like this. Sine theta, we're multiplying and dividing by theta. So, and then also the same thing with 4 theta. So like this. So sine theta over sine 4 theta over 4 theta times theta over 4 theta. Now, one thing you can do with limits is you can distribute them. So you can say, okay, this is the limit as theta approaches 0 of sine theta over the limit as theta approaches 0 of sine 4 theta over 4 theta times the limit as theta approaches 0 of theta over 4 theta. Okay, and we know that this first one is 1. That's the one thing that we need to know from, that's one of the basic limits that we need to know. Similarly, the denominator is 1 because as theta approaches 0, 4 theta is also going to approach 0. And then theta over 4 theta is actually always just 1/4. So this is just times 1/4. And thus my answer is 1/4. Okay, next question. A function g is defined as g of x is equal to x cubed minus 3x squared. First thing they ask us to do is to find the stationary points of g and the nature of those stationary points. So the first step is we need to find what g prime of x is. If I do that, I get 3x squared minus 6x. This is the power rule. You bring the power down and then reduce the power by 1. Okay, and now I need to, let's first also find g double prime of x, which just means differentiate again. I get 6x minus 6. Okay, for the stationary points of g, they are g prime of x equals 0. So that means 3x squared minus 6x is equal to 0. I can factor this as x times 3x minus 6 is equal to 0. And therefore the two stationary points are x is equal to 0 and x is equal to 2. But the next thing is that we need to find out the nature of these stationary points. How we do that is we use the second derivative. There's another thing that you can do. You can use what's called the first derivative test if you want, but I'm just going to use the second derivative test. So x equals 0, g double prime of x is just going to be 6 times 0 minus 6, which is just minus 6. Since this is less than 0, x equals 0 is a local maximum. Now x equals 2, g double prime of x equal to 6 times 2 minus 6 is equal to 12 minus 6, which is just 6, which is bigger than 0. Therefore, x equals 2 is a local minimum. So we've classified the stationary points of g now. The next part asks us to sketch the graph of g, showing its intercepts, stationary points, and any other important features. So the first thing that we should do is, since we're asked to find the stationary points, let's actually find what the stationary point is. Like we know the stationary point is x equals 0, but what's the y corresponding to this x equals 0? Well, when x is equal to 0, g of x is equal to 0 cubed minus 3 times 0 squared, so g of x is just 0. And g of x here is equal to 2 cubed minus 3 times 2 squared, which is 8 minus 12, which is equal to minus 4, right? Okay, now we need to find the intercepts as well. The intercepts mean what's the value of g of x when x is 0, and also what are the values of x that make g of x equal 0. So first of all, well, we just saw, x equals 0, we just did because it's actually a stationary point. But the most important thing is we need to find the root. So g of x equals 0, that is x cubed minus 3x squared equals 0. And that's the same thing as, like a factor in x squared times x minus 3 equals 0. And therefore it's x equals 0 like we saw before, and also x equals 3. So we have the important information that we need. So now let's proceed to graph this thing. So as we just showed, this point here has to be a local maximum. So it's going to, I'm just sketching very crudely right now, It's going to do something like this. And then it's going to turn around, right? And then we said that 2 was our local minimum. So it's going to then turn around at 2. This should be 2. And then it's going to cross, and the root is 3. So it has to cross at 3 and then go up all the way to infinity. So this is what the rough shape of the graph is going to look like. But now let's actually plot it. So they gave us a grid, so it would make sense for us to use the grid properly. So what we found was the point was 2 minus 4. So 2 minus 4 would be here, 2, that's 2, and then minus 4 is here, right? And then the next one is going to be 3, 0, 3, 0, so it's going to be something here. So let me just draw this in red so you can see. These are the 3 points that we'll have to connect with our graph. Okay, so, it's just to basically draw a graph now, connecting these. So hopefully my iPad pencil works well. It turns around here, comes back at 3, and then goes up, right? Should do this a little better than that. So yeah, it just goes up to infinity. And one way that you can do a quick sanity check, just this will help figure out if you made an error, is based on our graph, it seems that as x approaches infinity, g of x approaches infinity. And is that true? Well, yeah, because as x approaches infinity, the x cubed term dominates, and that goes to infinity. But based on our graph also, it seems that as x approaches minus infinity, g of x approaches minus infinity. And again, you can see that that's true, because the x cubed term dominates, and as x approaches minus infinity, x cubed will approach minus infinity. Okay, so that's a sketch of the graph, and it doesn't look the best, but it indicates the most important features. That's really what you need to show. In this video, we're going to look at question 6 of CAPE 2024 Pure Maths Unit 1. So the first part asks us to find the volume of the solid generated by revolving the region bounded by the graphs of x equals square root y and y equals square root x, y equals 2x about the y-axis. One thing you should underline when you read this question is that the revolution is occurring around the y-axis, not the x-axis. So if you just use the most standard formula, you'll actually get the wrong answer. You have to be kind of careful with these things. Let me just draw a quick sketch to show you what's going on. So let's say these are your usual axes, x and y. This is what y equals square root x equals square root y will look like. And then this is what y equal 2x will look like, something like this. And what they're saying is, okay, you're taking the region here and you're rotating it about the y-axis, right? I'll just draw an arrow to indicate what the y-axis is. So the first thing that we should do is we should figure out what point this is. Well, we can do that quite simply because we can just solve simultaneously. X equals square root y and y equal to x. So that means that x squared is equal to y and y is equal to 2x. That means that x squared equals 2x. And that means the 2 points are x is equal to 0 and x is equal to 2. So this point here is x is equal to 2. And the corresponding height, which is actually we need to know as well, is 4. Because y is 2x and x is 2. So also based on the graph, you can tell that the curve that's going to be above is going to be the x is equal to square root y curve, right? So we need to use our formula for the volume of solid at revolution. And the formula says, it's called the Washer method, but the volume is given by pi. And because we're rotating about the y-axis, our bounds have to be from y to y. So as we see, y is going from 0 to 4. And the curve that's further away is the x curve. So it's going to be x squared dy minus, well, this is x corresponding to the first curve, and then minus, same thing, the integral from 0 to 4 x squared dy. And I'll just put this in brackets. So I know it looks a little confusing, so let me just write this a little better. Y going from 0 to 4. Like in this first one, x is equal to the square root of y. So that means that x squared is just y dy. And then in the second one, x is equal to y over 2. So minus integral from 0 to 4 y over 2 squared. dy. Let's call this x1 squared and x2 squared. Anyway, so this is the formula that we get, and we know it's just a matter of computing the integral. So you can do this however you want. I'll just do this like this, y squared over 2 if you do the indefinite from 4 to 0, and then here it's minus integral from 0 to 4 y squared over 4 dy, and then this is pi. Okay, if I plug this in, the 0 will just be 0, and then 4 squared is 16, that is 8 here, minus y cubed over 12 from 0 to 4, and again the 0 term will just be 0, so it's just going to be pi 8 minus 4 cubed over 12. What's 4 cubed? 4 cubed is 64 over 12. Okay, and you can just put it in your calculator at this point. Whatever answer it is, right? Okay, but that's how you find the volume. Next question now. Diagram below, not drawn to scale, shows the graphs of y is equal to 2x cubed minus 6x and y is equal to 4x. Calculate the area between the line and the curve. Okay, so the graph that they gave us is very, very helpful because it's telling us exactly what we need, how we need to do our integration. What it's telling us is that first we need to find out what these 2 points are, which we'll do, but okay. When we find out what these 2 points are, we're first going to integrate from this point to 0 of, let's call this the cubic curve minus the line, and then because that's the one that's above, and then we integrate from 0 to this point of the line minus the cubic curve, right? So a picture in a question like this is always very helpful. That's why it's very nice that Cape gave you this picture. Also, if you want to do some extra credit, it kind of looks like these two areas are the same based on the picture, but you can't assume that. You don't know that. Can you try to show that this is the case? But anyway, let's actually do it now. So the first thing is we need to find the 2 points of intersection, and we solve the equation simultaneously. So we get 2x cubed minus 6x is equal to 4x, or 2x cubed minus 10x equals 0. Factor an x, 2x squared minus 10 is equal to 0, or x is equal to 0, x squared is equal to 5, and therefore the 3 points of intersection are x is equal to 0 and x is equal to plus or minus the square root of 5. So this point here is the square root of 5, and this point here is minus the square root of 5. So now we know how to calculate the area between the line and the curve, because the area now is going to be the integral from minus the square root of 5 to 0. In this region, it's the cubic curve that's above. So that's going to be 2x cubed minus 6x minus 4x dx. And that's one piece. Then the next part is going to be 0 to square root 5 of, now the line is above, so it's going to be 4x minus 2x cubed minus 6x dx. Now, once again, it's just a matter of carrying out our definite integrals. So you can do this as integral from minus square root 5 to 0, 2x cubed minus 10x dx, then plus integral from 0 to square root 5 10x minus 2x cubed dx. Now I can say, okay, this is going to be x to the 4 over 2 actually, and then minus 5x squared. And then the bounds are 0 and minus square root 5 plus, yeah, it's going to be 5x squared minus x to the 4 over 2. And then the bounds are square root 5 and 0. So now if I just put these in, the zeros are going to be 0. So then here it's going to be minus, and then square root 5 to the power of 4 is just 5 squared, so it's going to be minus brackets 25 over 2 minus 5 times 5, because x squared is going to be 5, x is square root of 5, and then plus, again the 0 term is just going to be 0, so plus 5x squared is 25 because x squared is 5, and then minus x to the 4 is 25, so minus 25 over 2. Okay, so in total it's minus 25 over 2 plus 25 plus 25 minus 25 over 2, which is 25 plus 25 is 50, minus 25 is just 25. So the total area bounded by these two curves is 25. Part C asks us to show, given that f is an even function, that the integral from minus a to a of f of x is equal to twice the integral from 0 to a of f of x dx. First thing is we have to understand what an even function is. So a function f is even if f of minus x equals f of x. So a few examples from functions that you know are f of x is equal to x squared, x to the 4, etc. Even powers, because when you put in the minus sign it goes away. Another example is cosine x. And the important thing about, well, visually what it means to be an even function is like, so this is the graph of cosine x for a little bit. It'll go on. But the important thing is like if you flip this side about the y-axis, you're going to get the other side. That's the whole point of an even function. So there's like a symmetry. And the question is basically asking you to show, like, for example, that this red area here is twice this blue area. And hopefully you can see visually why that's the case. But of course, that's not an actual proof. So let's do an actual proof now for why this is the case. So let's start the integral from minus a to a of f of x dx. This is what I can do is I can split this up, integral from minus a to 0 of f of x dx, plus the integral from 0 to a of f of x dx. Now here, I'm going to apply a substitution, y is equal to minus x. So that means dy is equal to minus dx. So now I can do this, and I have to change the bounds, because that means since y is minus x, the bounds are going to be from a to 0 of f of, well, x is minus y, so f of minus y, and then dx is minus dy, plus the integral from 0 to a of f of x dx. And then what can I do? Well, since there's a minus sign, I can absorb that into the bounds by just flipping the bounds. So it's integral from 0 to a of f of minus y dy plus integral from 0 to a f of x dx. Now I have to use that f as an even function, so f of minus y is the same thing as just f of y. This is integral from 0 to a of f of y dy plus integral from 0 to a f of x dx. But the thing is, y is a dummy variable here, which just means I can change it, I can call it anything I want. So I can change it to an x if I want, integral from 0 to a f of x dx for this y. If you want, you could think of this as doing u substitution with x equals y, if you really don't believe me. But really what it just means is like, once I change all my occurrences of y to x, the formula is still true, because it's what's known as a dummy variable. And then the other one will remain unchanged, integral from 0 to a of f of x dx. And then of course, if I just add the same thing to itself, I get twice the integral from 0 to a f of x dx, which is exactly what we wanted to show. For a little bit of extra credit, I'll ask you to show that if f is odd function, so if f is an odd function, the integral from minus a to a of f of x dx equals 0, right? Okay. Now let's move on to part D, which is a differential equation. It asks us to solve the differential equation x cubed y prime is equal to 2 minus x to the 4, given that when x is equal to 1, y is equal to 2. So we have to basically use our standard tricks to solve this differential equation. So what I can say is, okay, this is x cubed dy dx equals 2 minus x4. Divide by x cubed everything. So dy dx is equal to 2x to the minus 3 minus x, or dy is equal to 2x to the minus 3 minus x dx. And then I'm going to integrate both sides. So on this side I just get y is equal to, now I have to add 1 to the power and divide. So 2x to the minus 2 over minus 2 minus x squared over 2 plus a constant c. And now I can simplify this as, what is it, minus 1 over x squared minus x squared over 2 plus a constant c, which is equal to y. But they told us when x is equal to 1, y is equal to 2. So 2 is equal to minus 1 over 1 squared minus 1 squared over 2 plus c, which is minus 1 minus a half plus c. Therefore, c is equal to 7 over 2. And our full solution is y is equal to minus 1 over x squared minus x squared over 2 plus 7 over 2.